In this video, we're going to be writing the function for a transformed polynomial. So on this page, I just want to refresh our memories on what the different polynomial transformations can possibly be. Remember that we can either horizontally or vertically translate or move our functions around. We can vertically or horizontally reflect our graph over one of the two axes, and we can vertically or horizontally stretch or shrink our graph. Now, as we manipulate these functions to stretch, translate, and reflect the functions that we already have, we have a couple of things that we need to remember. First, we need to remember that anything that is a horizontal change, so that's going to be a horizontal translation, a horizontal stretch or shrink, or a flip over the y-axis. For anything that is horizontal, remember that it happens essentially inside a set of parentheses with x. You can see that here. You can see that it's happening inside. So we're going to have to remember that we're going to have to make this change on the inside of a set of parentheses that we add, and then we'll have to make this change to x. Then the other thing to remember is anything that is vertical. So a vertical translation, a vertical stretch or shrink, or a flip over the x-axis is going to happen on the outside. So we don't have to add in any parentheses, but we need to make this change on the outside. You can see all of these changes are happening outside of where x is. So we're going to have to keep that in mind as we actually translate these functions, because whether we're adding a value on the outside or the inside is going to be important. The other thing we need to remember is what happens with each change. So if we take a look at the translations here, the translations, which are these first two boxes, we know that we're always going to be adding or subtracting some value to the equation. Now, for horizontal, these work the opposite of what we expect them to. Remember, if we're going to the right, we actually are adding in a negative number. If we're going to the left, we're adding in a positive number. And for the vertical translations on the outside, where we add and subtract a value, those work just as expected. When we reflect over an axis, we're always multiplying by a -1 somewhere, whether that's inside or outside. And when we vertically stretch or shrink our graph, or horizontally stretch or shrink our graph, we're always multiplying by a value. But the thing to remember is that the vertical ones work as expected, while the horizontal ones, we actually have to use the factor that we're given to find our b value. Remember, b value equals 1 over our factor, or vice versa. Essentially, it means that this is it's a reciprocal of each other. So when you have a factor of 1/2, you flip that over to its reciprocal to find that our b value is 2. So keep that in mind as we work through the example on the next slide. So in this video, we're just going to go over one large example instead of going over multiple little ones. For this one large example, we're going to apply all 6 different types of transformations. Now, something to keep in mind is that the order in which we apply these does matter. So just make sure that we go in order, don't jump around, or you will get a different answer, because the changes, if we do them in different orders, will make changes at different times. So we're going to start with the first one, which is reflected over the y-axis. Now I know the y-axis is the vertical axis, and if I'm reflecting over it, I know that that is a horizontal change. Now, because there's a horizontal change, I know it's going to happen on the inside wherever x is. So for right now, I'm going to add in a set of parentheses to x. And what I'm going to do to x is I'm going to multiply it by a -1, because it is a reflection. So I'm going to take my original function here of f of x. I'm going to name it a new function, g of x, because that's its new name at the end of all of this. And then from here, I'm going to go inside of each parenthesis. So I have -1 times x all cubed. Notice I'm adding that -1 inside of the parentheses with x, so the -1 will be cubed as well. And I have plus 2, and then I have -1x all squared, and then minus 3 times the -1x. So because I'm reflecting over the y-axis, I've multiplied the inside of the parentheses I added, so where the x is, by -1. Now, what I know about -1 cubed here, so I can simplify this a little bit, is I know -1 cubed is negative 1. So this is going to become a negative 1 times x cubed. Plus, I know that negative 1 squared is 1, so this becomes 2 times 1x squared minus a negative 1 to no power, it's just negative 1. That becomes negative 3 times negative 1x. So after this first transformation here, g of x is negative 1x cubed plus 2x squared, and then I have a negative 3 times a negative 1, so that becomes plus 3x. So I've now taken care of this first transformation. I have reflected it over the x-axis by adding parentheses in around that x value and multiplying those x values by negative 1. Now, this next piece says we have a vertical stretch by a factor of 3. So I know that's when we multiply by an a value on the outside. And I know that my a value is going to be 3. So if I'm multiplying on the outside, I'm going to take the entire function surrounded by parentheses, and I'm going to multiply it by a 3, or my a value on the outside. So essentially what I'm doing is I'm taking every single component of this function and I'm stretching it to be 3 times its height, or I'm making it 3 times as tall. So all I'm going to do here is I'm going to multiply each coefficient by 3. So after this second transformation, I have g of x is equal to negative 3x cubed plus 6x squared plus 9x. So I've now taken care of this second transformation. All right. So this next one here, it's horizontally translated 4 units. Now this one, while it sounds kind of easy, is actually going to be a bit of work. So we're going to have to kind of keep that in mind. So let's go in and we're going to add on the inside a transformation to the right 4 units. So we're going to subtract 4 units from the inside. So here we're going to have negative 3 times, this is going to become x minus 4 cubed plus 6 and then x minus 4 squared plus 9 times x minus 4. Now, since we're trying to write these all into standard form, we are going to multiply them all out. So we're going to have to take some time here. What I'm going to do off to the side is I'm going to figure out what x minus 4 times x minus 4 is first, because I can figure out the squared piece then. So this would become, if I do a big distribution here and multiply all of those together, I get x squared minus 4x minus 4x plus 16. So that becomes x squared minus 8x plus 16. So this belongs here with the x minus 4 quantity squared. And then I can take this piece right here, x squared minus 8x plus 16, and if I multiply it by x minus 4 one more time, that will give me what it's equal to here. So this piece would become x to the third minus 4x squared. Then we get minus 8x squared plus 32x. And then we get plus 16x minus 64. So I just multiplied everything in the first parenthesis by everything in the second. So if I combine like terms here, I end up with x cubed minus 12x squared plus 16x minus 64. So this is some little math I did off to the side. If I go back to my original function here, I end up with negative 3 times x cubed minus 12x squared plus 16x minus 64. Then I also have plus 6 times x squared minus 8x plus 16 plus 9 times that x minus 4. So I've substituted in what x minus 4 cubed and x minus 4 squared are into the problem. Now if I just distribute all of my coefficients, so I distribute the negative 3 here to start, I end up with negative 3x cubed plus 36x squared minus 48x plus 192. Then if I distribute out the 6, I end up with plus 6x squared minus 48x plus 96, and then plus 9x minus 36. So my last step here is just to combine any like terms that I see. So I only see 1x cubed there, so I'll kind of underline these in blue so you can see them as I go. So this would now become negative 3x cubed. Then on the x squareds that I see 36 and 6, so those become 42x squared. We then have minus 48x and minus 48x. Those become a negative 96x plus 9, which becomes a negative 87x. And then you can see that we have 192, 96, and negative 36, which becomes a positive 252. So those horizontal translations can get a little bit dicey because you do have to apply them to multiple different areas and then square them and cube them as expected. So we've now crossed that one off of our list. That's the biggest one we're going to have to do. So now let's scroll down a little bit to give ourselves some room to work. And the next thing we're going to do is we're going to reflect over the x-axis. So for this particular problem, this is going to be a vertical translation because it's over the x-axis. So that means we just multiply the outside by a negative 1. So we're going to take everything on the outside here, multiply it by negative 1. So that changes our g of x value to be 3x cubed minus 42x squared plus 87x minus 252. So as we distribute out that negative 1, all it does is flip the sign of each term on the inside. So that one is now complete. The next thing we're going to do is we're going to vertically translate this graph so that it moves down 3 units. So this is going to be a subtraction of 3 on the outside. So that's our k value. So all we're going to do here is subtract 3 on the outside to move it down 3 units. That just gets combined with the negative 252. So we have g of x is equal to 3x cubed minus 42x squared plus 87x minus 255. And then our last change here is we need to horizontally stretch this graph by a factor of 1/2. So remember, these are the opposite of what we expect, so we need a b value, which is going to be the reciprocal of 1/2, which is 2 over 1, or 2. Then we know that our b value is going to multiply by x on the inside. So we're essentially going to add in parentheses here, and we're going to multiply that x value by 2. So this is going to become 3, and then it's going to be 2x cubed minus 42 times 2x squared plus 87 times 2x minus 255. So in this final step here, we'll essentially have to take that 2 cubed, which is going to be 8. So this becomes 3 times 8x cubed minus 42, and then we have 2 squared, which is 4x, plus we have 87 times 2x minus 255. So now all we have to do is multiply the two numbers in our coefficient. So our final answer here is going to be, okay, 3 times 8 is 24, x cubed. Then we have 4 times 42, which is 168 x squared, plus 87 times 2 is 174x minus 255. So the biggest thing here is remembering which transformations happen on the inside with x, where you have to add parentheses, and then which transformations happen on the outside, and then remembering how those values of a, h, k, and b are all altered as we perform those transformations. So you won't get a lot of problems where you have to perform all 6 transformations, but if you do, you now know how to walk through each and every one.